we need to be very available because we cannot stop the process at the harvest time. So high availability is one of the key points that are required for this kind of solution. And finally, we face small silos, but we face also very large companies, so we have to provide a solution that fits whatever the size of the silo you have to manage. If we look at what is existing on the market, we find mostly two types of solution. The first one is proprietary solution, a kind of black box. This kind of solution are developed by people coming from the grain company that said, I will develop my own solution. So they have a very high know-how, and they do something that fits very well the market. But it's a black box. Most of the people, most of the time, the know-how is only on the brain of one guy. The guy leaves, he leaves with the solution. This is not so much sustainable. And if you want to apply modification, it's costly and you don't have reactivity. So some pros and some cons. On the other side, you have open solution based on PLC Scada technologies from the market, but these solutions are the same one for water, wastewater, whatever, so they don't fit exactly the need of the market. So based on this fact and two different solutions we find on the market, Schneider decided to develop an innovative new solution to fit the customer needs. First one, generate easily and reliably a solution when we need to go to the market. Having something cost effective with a modern HMI to allow the people that are used to panels, buttons, and LEDs to accept the digital technology. We based this development on an EcoStruxure hybrid DCS platform, which is a general standard from Schneider Electric. And to digitize the silo, we developed a new library of objects. So to modelize the silo into the system, we use a library of objects developed for this particular purpose. The good point is that the solution is open because it's based on a standard platform from Schneider Electric. And it's sustainable because we, Schneider Electric, maintain the solution. So what is this EcoStruxure hybrid DCS solution? It's one single platform to manage devices. Industry device could be drives, starter, but also electrical device, protection, circuit breaker, power monitoring on field buses. And for the control of this application, we use Modicon M340 and M580 PLC. One more time, something field-proven, standard from Schneider Electric. Nothing new at this level. So for you, it's reliability because it seems something that we use everywhere in the world. And then we connect to this control level a supervision tool to allow the operator to monitor and to command the silo when he is getting the grain into the silo. So we developed a new library of objects based on years of expertise. So we embedded into the development team people coming from grain silo application that bring us the knowledge, the know-how about this kind of application. And we digitized their brain to put into the system libraries that fit exactly the process. The ergonomy is the one the people are used to. And the solution is open and flexible because it's based on traditional PLC Scada from Schneider Electric. So what are the components of an OptiSilo application? First of all, you have one computer, at least, because if it's a large application, you will have multiple operators and you can have multiple computers across the silo. But the minimum is having one machine to operate the silo, allowing the operator knowing what's happening, acting on the system, and commanding the system. This machine, at engineering time, will configure the system. But we can also use a different machine and download into the system the application that is configured. Then we will have a phase to configure and engineer the system, and I will go just after on this particular point. In the middle, we have the hardware layer, standard from Schneider, M340, M580, Modicon PLCs, and then we have the interface I/O with the field, with the silo that you can see here. So these are the different components that appear in the OptiSilo application. So now it's time to configure, to create the silo. The first point is modelization of the silo. On the left side, you see the drawing, the design, what that we call the PNID, piping and instrumentation diagram. You can see that we have elevators, conveyors, box multi-directions, slide gates. All these equipments are typical from a silo application. So, what did we do? We digitalized these objects, creating a library into the system. So we have elevator objects, conveyor objects, box objects, etc. And to create a silo, we drag and drop each one of these elements into the system to create the application. On the middle, you have the customization of the instances. One elevator has not exactly the same behavior than another one. The speed can be different. It can be one or two direction. Same for the boxes. The box can have sensors, open, closed, right, left, or no sensor. So on the middle, we customize in the system each one of these instances. And the result you get is on the right side. The code for the automation that will run into the PLC is built automatically by the system. You don't generate the automation code anymore. It's come from the system after the configuration phase. The next point is absolutely key, is linking all this equipment together. So as you can see here, one elevator put the grain into a box. This box puts the grain into a conveyor. This conveyor brings the grain into a cell. So we must tell the system all these links between equipments. So again, you have an interface inside the system that allows you to create all these links, making the system aware what are the possible mechanical ways, routes, between one point and another point of the silo. This know-how is transferred automatically into the system after this configuration phase. So, as a result, what features you get from OptiSilo? You get the supervision of the process. The operator sees how the silo is running. You get faceplate. Each equipment has one faceplate, allowing the operator knowing the state, stop, start, change some set point, etc. You get energy measurement. Energy efficiency is also part of the system. You get maintenance into the system. How many times my system has been running? How many times it has been operated? That allow to operate and maintain the plant easily. You get the route selection, because in a silo, to go from a point A to a point B, you have multiple mechanical possibilities. So in runtime, the user must select what route he wants to take. And the system will assist him, giving him all the possibilities that physically exist into the silo, and the user has just to select, I want this one, and then the automation will run automatically. We also take care of operator privilege, tracking. These are all the features that come out of the box after the configuration step of the system. We need to create the drawing to operate the plant. So each object of the library has a graphical component: elevators, cell, conveyors, slide gate, cleaners, etc. So the role is just to put on the screen the graphical object that will be linked automatically to the controller. I talked about the faceplate. This is what you get out of the box. Any equipment has its own faceplate to facilitate the life of the user. Operate, maintain, diagnose, command, optimize the system. These faceplates are coming out of the box. You don't have to develop anything. They are part of the library of objects, ready to use. Then, the key point of this tool, optimizing the route, is that when it's time to select a route, meaning you have a truck coming into the silo full of grain, and you want to put this grain in the cell 21 of your system. Then the operator selects a route. On the left side, he selects the origin of the grain. In this example, it's the cell 21. On the right side, he selects the destination. In this example, is a truck. In French, camion is truck. And then the system automatically proposes him the possible route that exists into the silo, because this is just physical and mechanical. The operator will select the one he wants for any reason, and then automatically the system will run this route, selecting and starting sequentially any of the equipment, and then taking the grain from point A to point B. This is done automatically, and it's really a huge assistant for the user that don't has to calculate by himself all the possible route. This is proposed by the system. The result of all of that is here. This is a real view of a real silo running. So you have here the entire set of equipments in the silo. You can see that we highlight with specific colors. So each of the 14 routes that are configured have one color. And as you can see here, all the equipments are circled by the route they belong to. And at a glance, the operator can easily see what's happening, what are the equipments used right now into the silo. So at a glance, the operator has an immediate understanding about what's happening in the silo and can take any decision in case of anything happen. Another possibility for the operator is to select the way he wants to work. This is configurable. On the left side, the operator selects, I just want to see the route I am using. That's easy for me. So in that case, we mask all the other equipment of the silo. User choice. On the right side, you have another choice. You see all the equipments of the silo. The ones that are running are in color, first layout, and the ones that are sleeping, let's say that, are in background, but at a glance, the user sees the status of all the equipments of the silo. This is user choice. Nothing to be programmed, just configuration when the application is built and the user selects the choices he wants. This is an integrated system, so we take care of all the information for the user. We track all the events. Everything that happens while running the silo is tracked and stored by the system. Alarms, events, operator action, set points. Everything that happens is tracked and stored by the system for further and later analyze in case of anything the user would like to understand later. On the middle, we have the status of the system. If it's multiple PLCs, IOs, computers, we have the diagnostic and the status of the system available out of the box. And on the right side, we have a trending tool available for the user to follow any energy consumption, running hours, status of the system. We can show to the user all this data for analyze to again optimize what's happening in the application. So this is what OptiSilo does for you, what we can take as takeaway. The first point is that this solution is based on very field-proven technologies from Schneider Electric. The second point is that it's maintainable and it's sustainable because we, Schneider Electric, are the owner and we are behind this solution. The third point, this is very scalable because we can start with a very small M340 PLC, and in case of need, we can go up to M580 with redundancy in case of high availability. So you pay for what you need, not what we want to sell you. The next point is integration of energy management. If you have instrumentation to measure the energy, the system will tell you how much you are consuming to put your grain from one point to another one. And that will allow you to optimize your process based on this energy consumption. The energy measurement will also be used to detect overload or that the system is empty, no more grain to transfer, so the system will stop automatically to save energy and not run the equipment for nothing. And then we have all other possibilities in this innovative solution to allow you to optimize everything. So, if you want to know more, if you want to see the detail, if you want to see how we configure this installation, if you don't believe that this is possible, please come and visit me on booth 38, and I have a real machine, not only PowerPoint, but I have an OptiSilo application running, and I will be able to show you how you configure and how you run and operate your plant. So please visit me, come at any time, and it will be my pleasure to show you that. Thank you so much for your attention, and see you later on the booth.